My gaming and editing PC is finally rebuilt, and today we're going to be looking at all of the parts that went into the build, also some overclocking, thermal testing, noise levels at full load, and of course some gaming benchmarks as well. I've got a couple more builds planned before the end of the year as well that I'm super excited about, so don't forget to hit that subscribe button if you don't want to miss out on those. So without further ado, let's look at all of the parts. Overall, this build will set you back around $2,300 US, and the goal for the build was to make it look as clean and tidy as possible, but still have some very decent performance and cooling. Fusion 2 will be editing all of the videos on the channel for at least the next few months, and will of course be powering the X34 Predator for ultra-wide gaming. So starting off with the choice of processor, I went with Intel's 6-core i5-8600K, which is surprisingly a decent step up from my previous 7700K in terms of editing and encoding times. I worked out that I'd be saving roughly 20 minutes on a typical video project, and I have a full video on that which you can check out in the top right hand corner. Now, in terms of overclocking, this thing has hit as high as 5.4 GHz at 1.45 volts, but this is an engineering sample, so don't expect to reach those speeds on a retail part. For a daily overclock though, I've got it set to 5 GHz at 1.25 volts, and that lower voltage means that we are able to keep those temperatures under control under heavy load. The CPU has been delitted as well, which improved temperatures by almost 20 degrees C. And I know a lot of you are probably thinking, look, I do a lot of multi-threaded workloads, video editing and things like that. So why didn't I go for something like the Ryzen 7 1700, which has 8 cores and 16 threads compared to the 6 cores and 6 threads of the 8600K? And while these processors are better for synthetic benchmarks like Cinebench R15 and other programs that are optimized to scale that well with core and thread count, the Adobe Media Suite really isn't. Programs like Premiere Pro, After Effects, and Adobe Media Encoder love high clock speeds just as much as they love high core and thread count. We'll be testing this in about a week or so if you do a lot of video editing, make sure to hit that subscribe button if you want to see that. Also, the 8600K does have better performance in high refresh rate gaming, and so it will make the transition to high refresh rate monitors in the future a little bit easier. Now, for the motherboard, I went with MSI's new Z370i Gaming Pro Carbon AC board, and this made a really good fit for the rest of the system. Being a Z370 board, we are getting a generous amount of VRMs, which does help improve CPU voltage stability and is of course very important for overclocking. The M.2 slot is located on the back where I've got the 250GB Samsung 960 EVO installed, and we are getting some very nice RGB as well, which just so happens to shine through the ventilated side panel and looks very nice in my opinion. We are getting built-in Wi-Fi as well, and I've found this to be very impressive and significantly faster than my previous solution. Now, I will be going more in depth on this motherboard in the full review coming up in a few days, so if you're looking to build a mini Coffee Lake system, then definitely keep an eye out for that. Okay, now onto the beast powering all of those frames, and of course we had to go with the GTX 1080 Ti. I picked up the EVGA SC2 for a few reasons. First and most importantly, it's a 2-slot card that actually fits inside the case, and that meant that I was able to sneak 2 120mm fans underneath as well. In terms of overclocking, I was able to achieve an extra 100 MHz on the GPU clock and 350 MHz on the memory, and that does give us a nice boost of about 6 to 8% in frame rate, but it does increase the temperature a few degrees. For memory, I really wanted to upgrade to 32GB, but as we know, memory prices are just ridiculous at the moment, so it's not really the best investment. So we're sticking with the 16GB of Dominator Platinum RAM clocked at 2666 MHz, which does the job just fine and of course looks very clean as well. Now, since we are stepping up the GPU and also up to a 6-core processor, it was time to level up the power supply as well. I was previously using the SF450 from Corsair, and this thing was an absolute delight to work with. The fan barely ever spun, and when it did, it was still whisper quiet. So when it was time to upgrade, I went ahead and stepped it up to the SF600. It's fully modular, 600 watts, and also rated for 80+ gold efficiency, and stays nice and quiet just like the SF450 did. When it came to the CPU cooler, it was a fairly easy choice to make after I have done a little bit of testing on a earlier video, and here we're going with the Noctua D9L with 2 92mm Redux fans, and I'm very happy with the performance I'm getting out of this. I've experimented with quite a few different cooling options, and this has been the most pleasing to work with by far, both in performance and acoustics. I'll be booting up and storing the majority of my programs on the 250GB Samsung 960 EVO, and the upgrade to an M.2 NVMe drive was totally worth it. Booting up is so quick and read and write speeds are very impressive too. And of course, the small form factor helps immensely as well, having all that storage in such a small form factor. I've also got two SSDs stored in the front, one 240GB and one 525GB, both which will be used to store games and other programs. Now, the sleeving is obviously a big part of this build, and after completing it all, I can honestly say it was one of the most fun projects I've had to work on. It's not the cleanest sleeving out there, but for a mini ITX build, I am pretty happy with how the majority of it turned out, especially this CPU cable which wraps around the back here and routes pretty nicely to the power supply. The motherboard 24 pin is something that I will probably redo in the near future. It was by far the hardest one to sleeve out of all of the cables since it's so complex, and I honestly thought it would look a lot cleaner in the end. Alright, now let's talk about the thermals, and a lot of you guys have asked whether that tempered glass side panel makes any significant difference, so let's start off with that. We can see that without the side panel installed, we get the coolest load temperatures as you would expect, and by the way, this was with Unigine Heaven 4.0 running, so your typical gaming load. Adding the stock ventilated side panel adds another 4 degrees for the CPU and almost 3 degrees for the GPU. And as we expected, the tempered glass side panel gives us the worst cooling performance and airflow. The CPU is now 3 degrees warmer than the stock panel, and the GPU is barely warmer at all. So in my opinion, the trade-off is totally worth it, seeing as the CPU is getting only 4 degrees warmer and the GPU temps aren't really changing at all. Now let's look at all the different temperatures under different loads, and let's start off with idle. Here we can see that there's some decent airflow in the system and that nothing is getting too warm just sitting there. Bumping it up to IDA 64 in our CPU load test, and all 6 cores averaged out to 68.5 degrees, with the GPU actually getting cooler here, and this is because the bottom intake fans are programmed to run off total system temperature and not for the GPU as they should be. So when the CPU is under load, those bottom intake fans are starting to ramp up, which is not exactly ideal. The 1080 Ti is pretty happy sitting there at 73.1 degrees C under your typical gaming load, and this was after I adjusted the fan profile to run it a little bit quieter and a little bit warmer as well, as it was a little bit loud out of the box. In the torture test with both IDA 64 and Unigine Heaven 4.0 running at the same time, the system was running like a jet engine. Here the CPU was sitting at 74.6 for an average of all 6 cores, and the GPU again is running cooler thanks to those bottom intake fans. Now speaking of noise, let's take a look at how the entire system sounded both at idle and also under full gaming load. So obviously not a quiet system. It's running at a similar noise level to Fusion 1, which had a much louder blower style card in it, but that also ran about 10 degrees hotter as well. So at least we are getting some improvement for the thermals. Alright, now time for the gaming benchmarks, and that's what this system does best since we do have the 1080 Ti in there. Now, in addition to the 1080p, 1440p, and 4K benchmarks, I've also thrown in some benchmarks at 3440 by 1440, seeing as that's what I personally use, and I know a lot of you guys are interested in ultra-wide gaming, so I am interested to see if Fusion 2 can power the 3440 by 1440 at 100Hz display. So starting off with Battlefield 1, which is what I personally play the most, and Fusion 2 is really doing quite well across all resolutions at ultra settings, and here we are pushing beyond that 100 FPS cap of the X34 Predator. In The Witcher 3 we're doing pretty well also, as you would expect, with a 60 FPS average at 4K, getting close to 100 FPS at 3440 by 1440, and then pushing some really solid frame rates at 1440p and 1080. PUBG is notorious for being very challenging to run and still looking like a potato, but here we are managing some very playable frame rates and at ultra settings too. When dropping things down to high settings, I was seeing frame rates above 90, and of course this was much more enjoyable given the negligible reduction in graphics. Dirt 4 is pretty demanding as well, and of course being a racing game that benefits from quick reaction times, a high refresh rate is definitely beneficial. Still though, excellent at 1080p, great at 1440p, but at ultra wide and definitely at 4K, I'd be dropping those settings down a couple notches. GTA 5 ran nicely, but of course pretty demanding with this list of settings. 1440p seemed like the sweet spot here with an average FPS of 83, and 1% and 0.1% of frames just shy of that golden 60 FPS. In Overwatch, the system was absolute overkill. Even at 4K here, we're pushing above 200 FPS, and with VSync enabled on the Acer X34 Predator, the system was almost idling as it only had to push 100 FPS. Prey was pretty easy to run as well, and seeing these results at 4K really convinced me that the system would be perfect for a mini gaming system in a living room, seeing as we are pushing around 60 FPS on average at ultra settings. And lastly, in Far Cry Primal, we are getting some very impressive performance again, but it's what you'd expect from the 1080 Ti being one of the most powerful GPUs currently available. So summing up, I'm really happy with how the entire system performs. The 1080 Ti is the perfect fit for the ultra-wide monitor, and the 8600K is a breeze to edit with as well. I still need to do a little bit of optimization for the fan curves, but I'm pretty happy with it so far. And if you guys want to see more build videos and follow-up reviews like this, be sure to hit that subscribe button if you haven't already. I've got a few builds lined up before the end of the year, so thank you to you guys. You guys said you wanted more builds, and that's what you're getting. So thank you all so much for watching. I'll see you all in the next one.